Water Resources Engineering 2, Unit 1, Gravity Dam. So, after knowing the theory part of this Gravity Dam, now then comes to the or now we will discuss about the some numerical solutions to check the stability of the dam. Here is given the problems to determine the hydrodynamic force and the moment about the base of the dam of height, that is the 90 meter. So, 3 meter with freeboard, and upstream slope is means 0.1 is to 10, 0.1 is to 1. So, means the 0.1, that is the vertical, no sorry, 0.1 is the horizontal and 1 is the vertical. Width, some top width of the dam is given the 8 meter, and the factor means this is the earthquake acceleration factor, that is the KH is given the 0.1. So, this is the problem. So, means how to or now to determine this hydrodynamic force and also the moment about the base. So, here is the slope is given means 0.1 horizontal is to 1 vertical, means 1 horizontal is to 10 vertical. So, theta is makes an angle the upstream face with the horizontal. So, tan theta is equal to 10. Okay. So, find out the value of the theta. So, theta is equal to tan inverse 10. 10 inverse 10, so that will come out the 84.29 degree, and the Cm is equal to the 0.735 theta upon 90. So, this theta is given, so comes out the value of the Cm. Now, in the relation for the dynamic pressure intensity means Pe is equal to the C KH gamma W into H. So, here the H is the 87 meter, because this is the height of the water is 87 meter. The total depth is given the 90 meter. So, total depth of the dam is the 90 meter. So, 3 meter this is the freeboard. So, the depth of the water this is the 87 meter, and gamma W means 9.81, and the KH is given, the value is the 0.1, and the C is equal to Cm by 2 in bracket of the Z, or now also you can say this is the Y upon H divided by the 2 minus y upon H plus under root of y upon H into 2 minus y upon H. So, this y, or now you can say this is Z, and that will equal to the H, means 87 meter. So, this if the value of the Z is equal to the H, so then the C is equal to the Cm, and the Cm is known the 0.688. So, then find out the value of small Pe. So, small Pe, that will comes out the 55.72 kilonewton per meter square, and capital Pe means hydrodynamic pressure force This is the 0.726 small p e into h. So, put the value of small p, so comes out this capital P E, and the moment of this hydrodynamic force about the base. So, this is the 0.299 small p E into h square. So, put the value of small p and find out the value of m E. So, this m E hydrodynamic force means capital P E, and small capital M E, that is the hydrodynamic the moment of this hydrodynamic force about the toe. And the next problem, that to determine the stability analysis of the Gravity dam with the following data. So, the overturning moment at the toe, that is given the 1 into 10 to the power 6 kilonewton meter. Total resisting moment at the toe means 2 into 10 to the power 6 kilonewton meter, and the total vertical force above the base is the 50,000 kilonewton. Base width of the dam is the 50 meter. Slope of downstream surface is the 0.8 horizontal is to 1 vertical, and calculate the maximum and minimum vertical stresses on the foundation, and also determine the maximum principal stress at the toe of the dam. So, assume that there is no tailwater and upstream face is vertical. So, this is the problem for the stability analysis, and now here the figure is given, and on the basis of this figure now already calculated the value of vertical forces. So, this is the summation of the vertical forces as well as moment about the toe, resisting moment as well as disturbing moment. So, now here is only check the factor of safeties and determine the stress. So, this is the very simple problems. So, here the factor of the safety against overturning, the summation of the MR upon summation of the MO or MD. So, put the value. So, this is comes out the 2. So, this is the more than or now in between of the 2 to 3. So, this is the safe against overturning. And determine the value of x. So, this is the point of location of the resultant from the toe. So, this is the summation of the m upon summation of the v. So, summation of the m means the 2 into 10 to the power minus 6, so 2 into 10 to the power 6 minus 1 into 10 to the power 6 divided by the 50,000. So, that will come out the 2 meter. So, this distance of the CG of the resultant force acting on the base of the dam from the toe. So, E is the eccentricity. So, that will come out the B by 2 minus x. So, this is comes out the 5 meter. And the PB maximum and PB minimum. So, in maximum now here is use the positive sign, and in minimum now use the negative sign. So, this is the PB maximum is equal to the summation of the V upon V 1 plus 6 E by B. So, this is the put the value of summation of the B and B and E. So, that will come out the stresses at the heel, and also find out the stresses at the hole, stresses at the heel. So, stresses at the, then find out this sigma means this is the principal stress. So, this is the PB sec square phi. So, 10 phi is given the 0.8, not 0.8. Okay. So, if this is the 0.8, so then find out the sigma at the toe. The other problem for the stability of the dam. So, the gravity dam that will shown in the figure, and determine the FOS means factor of safety against sliding and shear friction factor, as well as the maximum vertical stresses, and now here is shows is their tension and the principal stress and shear stresses by giving the value of the mu is 0.7 and the specific weight of the material, this is 24 kN per meter square. Unit weight of the water, this is the 10 kN per cubic meter, and the strength of the joint is given the 1400 kN per meter square. So, now this section is divided into the horizontal and the triangular part of the dam section. The section of the dam is given, this is the 30 meter depth. So, the 30 meter depth means 3 meter here is the freeboard and 27 meter this is the depth of the water, with 6 meter the top width, and the total width at the base width that is the 21 meter. So, now in divide into the two portions, means horizontal and the triangular portions. So, here find out the weight of the dam as well as hydrostatic force and uplift pressure force. So, hydrodynamic pressure diagram means 27 into 10. So, this is 270 and 270 this is for the uplift diagram. So, W1 and W2, W1 is the area of the triangle and acting at the acting at the 2/3 of 15. The W2 is the weight of dam of the rectangular portions of this dam. So, here the 6 meter width and the 30 meter is the height and 1 meter is the length. So, 6 into 30 into 1 into 10 this is the unit weight of the water and multiplied with 2.4. So, or now you can say this is 24. So, then it will comes out this 4320 kilonewton, and it is acting at the CG of this rectangular portion. So, that will comes out the 15 plus 6 by 2 from the toe. So, find out this moment is also. So, summation of the V1, so means W1 plus W2, and the summation of the means this resisting moment means this is the anticlockwise moment. So, means to add these two. Okay, now then comes to the uplift pressure. So, uplift pressure now in the diagram here is the shown the uplift pressure intensity, this is the 27 meter height of this water. So, this is the 27 into 10, that will come to 270. So, the area of this triangle, so this is comes out the 1/2 270 into 21, and it is acting the 2/3 of the 21. So, this is comes out the moment and the water pressure. So, this is the 1/2 gamma W H square. So, 1/2 10 into 27 square, and it is acting the H by 3. So, this is 27/3. So, the summation of the V is the summation of the V1 due to the weight and summation of the V2, that is the due to the uplift pressure. So, then the summation of the V1 minus U, that will comes out the summation of V, summation of H, that is the simply water pressure, and the summation of the means resisting moment, this is only for the weight, but the disturbing moment due to the water as well as due to the uplift. So, factor of safety, that is the ratio of the summation of the resisting moment divided by the, or the ratio of the summation of the resisting moment to the disturbing moment. So, then find out this one. So, this is the 1.57. So here this is more than 1.5, so this is safe against the overturning. And the factor of safety against sliding, so FSS, this is the mu times of the summation of the B upon summation of H. So this is comes out the mu is given the 0.7 and so it will less than the 1. So this is the unsafe against the sliding. And the shear friction factor, this is the SFF is the mu times of the summation of the B plus BQ upon summation of the H. To put the hourly value, so Q is the given is the 1400, so that will be more than the 9. So that will be comes out the 9. So this is the more than the 3 to 5. And the PV maximum at the toe. So this is summation of the B upon B 1 plus 6 E by B. Here the E, how to find out this E? So find out the X bar, summation of the M upon summation of B. So then comes out this one 8.115, and E is equal to the B by 2. So this B by 2 minus this one, so 2.38. So that is the B by 6 means 21 by 6. So that is less than of this B by 6. So there is no tension at the heel. Then PV, so PV maximum, that will comes out the put all the value, then get find out this the PV maximum. Then the principal stress is at the toe, so PV sec square phi. So tan phi is given the 0.75 in figure. So find out this value means sigma at the toe as well as tau at the toe. So this is the another examples here. The dam is trapezoidal in form with 4 meter the width is the 4 meter at the top and the 45 meter at the bottom, and the depth of the water 45 meter with 2 meter free flow. So now here to find out this is the stresses at heel and the toe by considering only the weight of the dam, uplift pressure. So uplift pressure taken as a 2/3 of the hydrostatic pressure. So means that is the uplift pressure is taken as means the uplift pressure intensity is taken as the 2/3 and hydrostatic force, and the gamma C is and gamma W is given. So, first find out the weight W1 and W2. So, W1 that is for the rectangular portions and W2 for this the triangular portions, as well as the hydrostatic force. So, means 1 by 2 gamma W H square, and uplift forces. So, this is the 2/3 of the 2/3 of this the hydrostatic forces. And here by using the same relations, this is the P B, that is comes out the summation of the means direct stress plus the bending stress. So, this summation of the F is comes out the W1 plus W2 minus uplift pressure. Okay. And then this is the area at the base, this is the 1 meter length with 45 is the base width. Then find out the summation of the moment of all here. So, means the anti-clockwise moment for the weight and the clockwise moment for the uplift pressure, and as well as the moment, the clockwise movement for the water pressure. So, that will comes out the summation of the M, and if summation of the M is known, then put the value, then get the stresses at the heel and the toe, or either way. Now, the find out the resisting moment and disturbing moment. So, then find the summation of the M. So, that is the same thing, है ना? So, and divide by the summation of V. So, that will comes out the X bar from the toe, and the E is equal to the V by 2 minus X bar. So, then comes out the E, and put this value in the PV is equal to the summation of the V upon B, 1 plus minus 6 E by B. So, then again comes to the same result. So, you can check the answer will be the same. So, complete the unit 1 and the submit the assignment within time. So, thank you very much.